Hello, I am Lakshman Maaheshwary, and today we are going to talk about Chandrayaan 2. And yes, it was made in India. If I am to summarize the entire mission in just a few words, they would be a giant leap. Yes, indeed, this was a giant leap for India. This was a highly complex mission which represented a significant technological leap compared to the previous missions of ISRO. This brought together an orbiter, a lander, and a rover with the goal of exploring the south pole of the moon. This was a unique mission which aims at studying not just one area of the moon, but all the areas combining the exosphere, the surface, as well as the subsurface of the moon, and mind you, in just a single mission. But before I talk about Chandrayaan 2, let us talk about the story till Chandrayaan 2. On 15th August 2003, Chandrayaan program was announced by the then Prime Minister Shri Atal Bihari Vajpayee. On 22nd October 2008, the Chandrayaan 1 took off from the Satish Dhawan Space Center at Sriharikota. On 8th November 2008, Chandrayaan 1 entered a lunar transfer trajectory. On 14th November 2008, the Moon Impact Probe ejected from Chandrayaan 1 and crashed near the lunar south pole. However, it confirmed the presence of water molecules on the Moon's surface. By 20th August 2009, the Chandrayaan 1 program came to an end. Now let us talk about Chandrayaan 2. To be honest, we had a slow start. On 12th November 2007, representatives of the Russian Federal Space Agency, Roscosmos, and ISRO signed an agreement for the two agencies to work together on the Chandrayaan 2 project. However, the mission was postponed in January 2013 and was rescheduled to 2016 because Russia was unable to develop the lander on time. Further setback came when Russia had a failure on its Mars mission. Roscosmos withdrew in wake of the failure of the Phobos Grunt mission to Mars. And when Russia finally cited its inability to provide the lander even by 2015, India decided to develop the lunar mission independently. But hold on, why go to the moon? Well, the moon is the closest cosmic body at which space discovery can be attempted and documented. It is also a promising testbed to demonstrate technologies required for deep space missions, the ambitions of which India holds dear. Chandrayaan 2 aims for enhancing our understanding of the moon, stimulate the advancement of technology, promote global alliances, and inspire a future generation of explorers and scientists. Now let us talk about the specials of Chandrayaan 2. With this mission, India would have been the first country to conduct a soft landing on the moon's south polar region. It was also India's first expedition to attempt a soft landing on the lunar surface with homegrown technology. If this mission would have been a success, India would have become only the fourth country ever to soft land on the lunar surface. Let us talk about the mission objectives now. First and foremost, this was a made in India mission. We aim to demonstrate the ability to soft land on the lunar surface. We also wanted to operate a robotic rover on the surface. The orbiter will map the lunar surface and help to prepare 3D maps of the surface of the moon. We wanted a peek behind the shadow. The scientific objectives were a little more detailed. Well, moon provides the best linkage to Earth's early history. It offers an undisturbed historical record of the inner solar system environment. Even though we have a little understanding about the evolution, extensive mapping of lunar surface will provide essential traces to the origin and evolution of the moon. Further, remember we talked about the discovery of water by Chandrayaan 1. Well, it requires further studies on the extent of water molecule distribution on the surface, below the surface, and in the exosphere of the moon to address the origin of water. The lunar South Pole is especially interesting because the lunar South Pole area remains in the shadow much longer than the North Pole. There could be a possible presence of water in the permanently shadowed areas around it. Last but not the least, South Pole region has craters that are cold traps and contain a fossil record of the early solar system in its pristine condition. We also aim to conduct a few scientific experiments. We want to have a better understanding of the lunar surface by doing detailed study of topography, seismography, mineral identification and distribution, surface chemical composition, thermophysical characteristics of the topsoil, and composition of lunar atmosphere. The orbiter payloads will conduct remote sensing observation from a 100-kilometer orbit. Now we come to the launch vehicle, which is Geosynchronous Satellite Launch Vehicle Mark III or GSLV Mark III. This three-stage vehicle is India's most powerful indigenous launcher to date and is capable of launching 4-ton class of satellites to the geosynchronous transfer orbit. The three stages are S200 solid rocket boosters, L110 liquid stage, and C25 cryogenic upper stage. The key payloads on the Chandrayaan 2 mission were Chandrayaan 2 large area soft X-ray spectrometer, imaging IR spectrometer, synthetic aperture radar LNS band, orbiter high resolution camera, Chandra's surface thermophysical experiment, alpha particle X-ray spectrometer, and laser-induced breakdown spectroscope. The orbiter on the mission weighs around 2,379 kgs and it has electric power generation capability of 1000 watts. It is capable of communicating with Indian Deep Space Network IDSN at Bayalu as well as the Vikram lander. The orbiter structure was manufactured by Hindustan Aeronautics Limited and delivered to ISRO on 22nd June 2015. The precise launch and mission management has ensured a mission life of almost 7 years instead of the planned 1 year. The lander named Vikram weighed 1471 kgs and had electric power generation capabilities of 650 watt. It was named after Dr. Vikram A. Sarabhai, the father of the Indian space program. It also had the capability to communicate with IDSN as well as with the orbiter and rover. It was designed to execute a soft landing on the lunar surface. The envisioned life was 1 lunar day, which is equivalent to about 14 Earth days. Now you may wonder why just 1 lunar day. Well, after 1 lunar day, the temperature would drop to below freezing temperatures and the electronics on board will start malfunctioning. Our rover was named Pragyan. It weighed 27 kgs and had electric power generation capabilities of 50 watt. It was a 6-wheeled robotic vehicle and the name translates to wisdom in Sanskrit. It had 2 instruments on board to test the chemical and mineral composition and also study the rock and soil formation on moon. Now here's the most interesting part. The whole mission was planned in just 960 crores, which is roughly 140 million US dollars. Yes, you heard it right, 960 crores. To give you an idea about what 960 crores is, films like Avengers Infinity War costed 2,169 crores and the Avengers Endgame costed 2,443 crores. As you can see, even these movies had much higher budget than ISRO's Chandrayaan 2 mission. Let us quickly recap the highlights of the mission. This was a lunar orbiter, lander and rover mission, and the duration of the mission was 1 year for the orbiter, 14 days for the lander and 14 days for the rover. The launch mass was approximately 3,850 kgs and the launch took place on 22nd July 2019 from Satish Dhawan Space Center, Sriharikota. It was carried by a GSLV Mark III rocket and the intended touchdown on the moon was 7 September 2019. So, let the journey begin. It all started on July 21st, 2019. The launch countdown of GSLV Mark III M1 Chandrayaan 2 commenced at 18:43 hours. The launch was scheduled at 14:43 hours on July 22nd, 2019. On July 22nd, 2019, at the designated time, the GSLV Mark III M1 was successfully launched from Satish Dhawan Space Center second launch pad. The Honorable Prime Minister of India congratulated Team ISRO for the successful launch of Chandrayaan 2. So the timeline of the mission, if we talk about, starts way back in September 2008. The launch date was July 22nd, 2019. The orbiter lunar orbit insertion happened on August 20th, 2019, and the orbital experiments are going on. Here you can have a look at the mission sequence. This information is sourced from ISRO's launch kit. Now let us come to September 4th, 2019. The second deorbiting maneuver of Chandrayaan 2 spacecraft was performed successfully and the duration of the maneuver was roughly 9 seconds. At this point, the orbit of the Vikram lander was 35 kilometers by 101 kilometers. The Chandrayaan 2 orbiter continued to orbit the moon in an orbit of 96 by 125 km. At this stage, both the orbiter and lander were healthy. The lander was scheduled to power descent between 100 to 200 hours IST on September 7th, 2019, which was to be followed by touchdown of lander between 1:30 to 2:30 hours IST. And then came the heartbreak for the nation. Please remember, Chandrayaan 2 mission was a highly complex mission. For the first time, ISRO brought together an orbiter, lander and rover, and that too to explore the unexplored south pole of the moon. Although the Vikram lander followed the planned descent trajectory from its orbit of 35 kilometers to just below 2 kilometers above the surface, at this point all communication with the lander was lost. According to ISRO, the success criteria was defined for each and every phase of the mission. Until September 7, 2019, almost 90 to 95% of the mission objectives were accomplished. Just to give you a perspective of the statistics, a total number of 38 soft landing attempts have been made so far, out of which the success rate is just 52%. On September 10th, 2019, Vikram lander was located by the orbiter of Chandrayaan 2. However, even after a lot of attempts, no communication could be established. As of September 19, 2019, all payloads of orbiter were powered. Initial trials of orbiter payloads were completely successful. The orbiter continues to perform scheduled science experiments to complete satisfaction. A national level committee consisting of academicians and ISRO experts were trying to analyze the cause of communication loss with the lander. Here you can see some of the valuable high-resolution photos sent home by the orbiter. In this image you can see boulders on the surface of moon. Here you can see a close-up view of the lunar surface. With the loss of the lander and the rover, one dream came to an end. But this is just the start of another dream. Let me introduce you to Chandrayaan 3. This is a robotic sample return lunar mission which will be carried out in collaboration of ISRO and Japan's JAXA. We would send a lunar rover and lander to explore the south pole region of the moon in 2024. This video was about mission Chandrayaan 2 and was brought to you by Lakshman Maaheshwary. Thank you for watching. Have a good day.